We are ready to, boom goes the dynamite, talk about probability and applying it to ratios. We are going to look at only the first three examples on your note sheet. You can disregard example 4 and the stuff at the bottom of the note sheet. We're going to keep things short and sweet here for today's section. So when we look at calculating the probability of an event, now that is noted with this capital P means probability, and then in parentheses, event. That's what I'm trying to calculate the value of happening. So how I'm going to calculate the probability of an event as a ratio is take my number of favorable outcomes and divide that by the possible number of outcomes. Now, favorable doesn't always mean a good thing. Like if I wanted to find the probability that I get killed in a car crash today, the favorable event is me being killed in a car crash. Now, my family would probably, and maybe even some of you would think, ooh, that would not be a favorable life event. But in the terms of that calculation, the favorable event, the event that you are trying to find occurring or happening, is me being killed in a car crash. So, anyways, another term that you may see is sample space. Now, a sample space is just a list of all possible outcomes, favorable and unfavorable. So, we have, first example here, we are going to draw a card from a deck of 52. Now, a deck of 52 cards, there are 4 suits. Now, no jokers in the deck of 52. We've got hearts, diamonds, clubs, and spades. In each suit here, hearts, diamonds, clubs, and spades, there is a ace through king, which is 13 cards, an ace through king, another 13, and an ace through king, ace through king. So there's how you get your 52, 13, 26, 39, 52. So your cards are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king in each suit. So I want to find now in this first example, what is P, the probability of my favorable event, in this case, is drawing a heart from a deck of 52 cards. So my number of favorable outcomes, there are 13 hearts, 13 favorable out of 52 possible outcomes. When possible, you can reduce 13 over 52 becomes 1/4. So you would have a 1 in 4 chance of selecting a heart from a full deck of 52 cards. Another example here, we have one letter out of the word center, C-E-N-T-E-R. We're going to, take those letters, put them on little slips of paper, throw them in a hat, a bucket, close our eyes, and pick a letter out from those 2, 4, 6 total. So I want to find what is the probability that I would select a vowel. For ease's sake, yes, there are situations where it may not be the case. We're going to define vowels in Algebra X as A's, E's, I's, O's, and U's. Yes, some people say sometimes Y is a vowel. I think in the word my, M-Y, Y might be a vowel. Don't quote me on that. I'm not saying it is, but I think it might be. And I could be wrong. So my favorable number of letters, in this case, how many letters are vowels? I've got 1, 2. I've got 2 E's, so there are 2 favorable out of 1, 2, 3, 4, 5, 6 total. So 2 favorable out of 6 possible, that would reduce to 1/3. So again, not terrible difficulty here, but again, paying close attention to detail and figuring out what number is your favorable and then how many possible outcomes. Here's kind of a fun one for you for basketball fans. Michael Jordan, Chicago Bulls. I guess he played for the Wizards too for a year or so at the end of his career. He was an 82% free throw shooter. That means if he was shooting a free throw, he would make 82% of his shots. So you could think, oh, if he shot 100 times, he'd make 82 on average. The question is now, not what is the probability he makes his next attempt, but what is the probability he misses his next attempt? Well, probability of a make, we said, was 82 out of 100. Probability of a miss, then, would be if he makes 82 out of 100, well, the other number would be misses. You either make your shot or you miss it. So if you take your total 100 and subtract 82, you would see that he would miss 18 out of 100. Another way you can think of that, if you use the percentage, 100% minus 82% would be 18%. So either way is fine by me. Ratio 18 over 100, you can divide that 9 over 50 or 18%. Either way is fine. I'm actually going to take a look here at your assignment and do the first 3 with you, just to get you going on the right track. So question 1, we have this table where we are going to look at a driver collecting data on how long it takes to drive to work. So we have got a total of 4 trips that take 20 minutes, 8 trips that take 25 minutes, and then 2 trips that take 30 minutes. So there are a total of 4, and 8 is 12, and 2, 14 total trips measured. And there are 3 different time intervals, 20, 25, or 30 minutes. So question 1, we want to find what is the probability the trip would take exactly 25 minutes. So that is going to be my number of favorable outcomes. There are 8 25-minute trips out of the total number of trips that were collected, 14. So 8 out of 14, and that would reduce to 4 over 7. Question 2 on the assignment says, what is the probability the trip will take 20 minutes? Well, there are 4 favorable trips out of the 14 total. And we can reduce dividing by 2 and get 2 over 7. And then finally, question 3. What is the probability the trip will take at least 25 minutes? So at least 25 means 25 or more. So both 25 and 30-minute trips would be favorable. So we would write that as probability of greater than or equal to 25. So there would be a total of 8 and 2, 10 favorable outcomes out of the 14 possible, which would reduce to 5 sevenths. So hopefully that gets you a good start as you look at the student birth months there on questions 4 through 9. There are a total of 25 X's, so each X represents 1 student, so there are 25 students in that class. Fly on, let me know how many questions you may have, and I'll be happy to help you out. Have a good one.